कोई आशा नहीं साउंड साउंड ठीक है शुरू स्टार्ट करছি I'm starting it. Okay. Hello students, so today we are going to learn about the set concepts. Okay, so here you can see the chapter's name, the set concepts, which you have also learned in class 7, and today we will start it from the beginning. And so let's start it. Okay, first of all we have to learn that the basic concept of set or the set theory, which is a set is a well defined collection of distinct objects considered as an object in its own right. These objects are called the elements or members of the set. Okay, so from here what are the things so from here what are the things we are getting to know first time, that a set is a well defined collection distinct objects. Okay, so the set, so when we will call anything as set, that when that is well defined a collection or a collection, and obviously the distinct object is called to be set. Okay, so let's see here. So what I have said, that well defined, secondly distinct, and thirdly is a collection. So in first we can see that here we have 5 types of shapes. Okay, the 5 types of polygons are here. So we can tell that this is a set of polygon. Okay, the next one is, it's a set of 1, 2, 4 and 8. So both these 4 are the numbers and they are all the multiple of 2. So we can say this is a set of multiple of 2. Set of multiple of 2. The third one is, you can easily distinguish that this is a bear, this is a lion, and this is a rhino. So this is a set of wild animals. Okay, and the fourth one is a set of flowers. So every set is a collection well defined objects, and everyone is distinct from another. So these all kind of things we can say that a set. Okay, let's do a little activity here. Here you can see that in my right hand there are 5 blocks, and in my left hand there are also 5 blocks, and these blocks are of green color and these blocks are in gray colors. So can we tell that these all are the sets? Yes, we can tell that, but but are these elements or objects distinct? No, these are not distinct. Yes, it has something, I mean they all have some quality that we can differentiate one from another, but in our eyes these all are the green blocks. So what we can do to call it as a set of green blocks? So one thing we can easily do is to write 1, 2, 3, 4, 5. This if I write this, so then this will become a set of green blocks of distinct blocks. Okay, and the same thing which we can do with these blocks as well. Okay, these will all called as a set of gray blocks if we write or distinguish all these blocks by writing 1 2 3 4 5 in it. Okay, so got it. So now we will do some real activities or real sums in the next slide. Okay, so a set where the elements of a set are 1 2 3 and 4 is a set containing the numbers 1 2 3 and 4, where 1 2 3 4 these all will one, 2, 3 and 4, these all will be called as the elements or objects of this set. Okay, and they will be denoted by preceding a second bracket and ending the second bracket as well. Okay, so here A is a set whose elements are 1 2 3 and 4. So we will denote a set like this. Okay, where 1 2 3 4 are the members or the objects or the elements of any set. Got it? The next one. So in set theory we generally use some symbols which are especially we talked about two symbols. One is like this. This is the epsilon symbol in Greek alphabet. In set theory we write this to denote this word, and if I write this, then this will be read as not belongs to. Like this there are so many symbols are already there. Like this one is called as such that, and currently these are the fine, and more we will go further, more we will learn about all the symbols or the notations. Okay, so here the symbol belongs to or epsilon stand for is an element or is a member, whereas the symbol not belongs to stands for does not belongs to. Okay, so here it's been given a set P where 3 6 8 13 and 18 is a set where 3 is a member of this set, so we will tell that 3 belongs to P, and here there is no 5 in this set, so 5 is not belongs to P. Just like similar we can say that 6 is belongs to P but 10 is not belongs to P, or 8 belongs to P but 15 is not belongs to P. Okay, the next one. Elements in a set can be written in like this, that which I have told it a few slides back, that we always denote or write set by putting second bracket in it. Okay, just like in this set A, B, C, D are the elements or members of this set. So this is denoted by like this, like same, and this same goes for B, D, A, C and C, B, D, A. Okay, and the next point we will learn that elements in a set should not be repeated. Just like in the definition we learned that the set when we will call anything a group of collection set, when they will be distinct. Just like in this activity I have also showed that this will be called as a set of green blocks if we distinguish every blocks by putting 1, 2, 3, 4, 5 in it. Okay, so in set there will be no repetition of elements or members. Okay, so let's understand this thing. Like if I write 1, 1, 2, 3, 4, 4, this won't be a set, cause this set has 1, 2, 3, 4, 5, 6. This set is trying to showcase 6 elements, but here 1 is being repeated, 4 is also being repeated. So this is not a set. But if I write like this 1, 2, 3, 4, this will be called as a set, because here every element is distinct from another. Okay. So next one, that how we will represent or write the set, or how we generally use set by defining it. So a set is generally represented in description method or form, set building method or rule method, and third one is the tabular method or the roster form or roster method. Okay, so now we will learn everything in detail, that why we are calling these names like this. Like n is the set of natural numbers. Okay, this is known as the description form. Just like we can say that R is the set of real numbers. This is also an example that how we write the set or denote the set in description method. Okay. The next one is the same goes for like this n. We know that n means the natural number which starts from 1 and goes up to infinity or countably infinity. So n, here n is 1, 2, 3, 4 and 5. This is known as the roster form or tabular method of denoting it. Now tell me how we can write R in this tabular method. So in tabular method, R will be also written as like this, -3, -2, dot dot dot. Here we can include some fractions onto it, 1/2, 3/2, dot dot dot, 5, dot dot dot. Okay, real number is not included in your syllabus, but if we want to write real number as also in the set form, so this will be as a real number. Okay, but in your syllabus we have also integers, and integers is also denoted like this, I. So if we want to write integers in this roster method, we will write it as okay, just like this. The third one is the set building form or the rule method. Okay, just like n where x, okay, we are writing it as second bracket starting x such that x is a natural number or x such that x belongs to n. Okay, simply it's meaning that x is the elements, these 1, 2, 3, 4, 5, these all elements are denoted by x. Okay, so second bracket starting x such that x is a element of x such that x is a natural number, and we will close the second bracket. So this is how we can use set or write the set in the set building form or the rule method. Okay, and just like I have said it earlier that this symbol stands for such that. Okay, so all done. The next one, okay, so now we will try some question and answers. Okay, so here first question is telling me that in a school there are 40 students in total, where 25 students are enrolled in the science stream, 20 students are enrolled in the commerce stream, and 10 students are enrolled in both streams. Where S represents the set of students in the science, C represents the set of students in the commerce, and so we have to write these two sets as the description form, roster form, and set building form. Okay, so let's see it how it's being written. So total number of students 40, students enrolled in the science stream 25, students enrolled in the commerce stream is 20. So if we write it as a description form, so set of S denotes the students who are enrolled in science stream, and set of C is denoting students who are enrolled in the commerce stream. Okay. And if I say that there are few students who enroll in the both stream, so we can denote that set in like this set B. Okay, where we can write that students who are enrolled in both we can write that set like this, okay, in description form. The next one, so here we are writing this as a roster form, just like we can say that. So just think in your class, in your classroom, there are some students who likes football and there are some students who likes cricket. So if I want to differentiate these two sets, so how I can, so I can just stay in the class and call your names. Okay, just like if I say that Vivan, you likes cricket, you stay there. Vedanshi, you likes football, you stay here. Okay, so here these names are denoted like student 1, student 2, student 15, student 16, and that's all. You can think it or you can play it by yourself in your school or in your class, just telling the names. Okay, this goes like for C set as well. Okay, the next one. Okay, now we learn the set builder form. Okay, in set builder form we can describe S as the set of all students who are enrolled in the science stream. This can be written as okay, this it has become a little hazy. I am writing it again. Here we will write like this, like X second bracket starting X, such that X is a student enrolled in the science stream. Okay, and in for C we can also write that maybe X such that X is a student, and after that all who has enrolled in the commerce stream. Or you can change the variable as well, like if you are taking X as the science stream students, you can take Y as the commerce stream student as well. Whatever you can, you say it doesn't have any kind of limitations that we can take the variables like fixed variables or something. It's nothing like that. We can take any other variable we want to. Okay. Okay. Set building for. The next one is the cardinal numbers. Okay. So the cardinal number or the simply cardinality of a set is the number of elements in the set. It tells you how many distinct elements are present in the set. If a set is finite, the cardinality is simply the count of the elements. For example, I know it, you guys maybe have been puzzled like this. Okay, so the cardinal number is simply the number of elements or the number of members in that set. Like if I write a set, if a set called A has these 5 elements, so as per the definition of cardinal number or the cardinality, the number of members is 5. So the cardinal number of this set will be 1, 2, 3, 4, 5. So which we can write like this. Or we can write like this. So the set A has the cardinal number of set A will be 5, or the cardinality of the set A will be 5. We can read it like this. Okay. Okay. So before going into that, we will do a little okay, we will do a little questions to understand it further. So just like here we have to identify the set, whether it's a set or not. Like the first one, the collection of all prime numbers less than 50. So if I write this set in just like the tabular form, so what? A collection of all prime numbers less than 50. So prime numbers, we know that prime number starts from 2. So it will be 2, 3, 5, 7 and dot dot dot. So we can clearly say that it is a set. So yes, this will be a set. The collection of all tall students in your class. No, this won't be a set. Why no? Because like there are so many tall students, like there will be so many tall students in your class 8. So there will be tall students in your class. So we can write this like this. There are also tall students in class 7. Okay. There are also tall students in class 5. Now, but tell me, the tall students in class 5, will they can beat the short students of your class 8? No, na, they won't. 5वीं क्लास के जो सबसे लंबे स्टूडेंट्स होंगे, क्या वो 8वीं क्लास के शॉर्ट स्टूडेंट्स को बीट कर पाएंगे? कुछ लोग शायद पाएंगे भी, लेकिन सभी तो नहीं पाएंगे ना. तो यहाँ पर इन्होंने इसको डिफाइन नहीं किया दैट ऑल टॉल स्टूडेंट्स का मतलब क्या है, क्या और ऑल टॉल स्टूडेंट्स का क्राइटेरिया क्या है, कितना सेंटीमीटर्स होना पड़ेगा टॉल स्टूडेंट्स बनने के लिए, ऐसा कुछ इन्होंने नहीं बताया है. सो दिस सेट इज नॉट वेल डिफाइंड, सो दिस वोंट बी अ सेट. ओके. The third one, the collection of all months in a year with 31 days. Yes, this will be a set, because in this set there will be January, March, May, and there are so many. So this is a well defined set, so it will be a set. Okay, 4 and 5 I am giving you as homework. Okay, the next one is representation of set. Okay, set of natural numbers less than 10. Okay, we have to just write the members of this set. So how we can write this? Okay, you can think about it. we can just simply write this as 1, 2, 3, 4, 5 dot 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 and like up to 9. So this is a set. The set of letters in the word mathematics. So how can we write this? Here we can write M A T H E I C S. This will be the all as the set including all the members. Why? Because see there here are 2M, 2A, 2T. Okay, we won't repeat them. So in mathematics word there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 words. Okay, but in the set of mathematics or the set which includes the spelling of mathematics, it will be 1, 2, 3, 4, 5, 6, 7, 8 members only. Okay. The third one is the set of even numbers between 1 and 20. So this is like same as the number 1, which you guys can do easily. And the fourth one is the set of states in India starting with the letter M. Maybe there will be 3 states in India which starts from the letter M, which you can tell easily. Okay, that's your homework. And the number 5 is the set of multiple of 5 less than or equal to 50. This is also very easy one. You guys can do it. Okay. Okay. The third one is the examples of types of sets which we haven't learned yet. Yes, we are going to learn it by continuing this class. Okay, so here are total 8 types of sets we are going to learn about, that how many sets are or what kind of sets they are. The first one is the finite, infinite, empty set or null set, disjoint set, joint set, equal set, equivalent set and singleton set. Okay, there are also some kinds of sets, but they are not that much popular or that much important to learn about. So the first one is the finite set. A finite set is a set that contains a specific number of elements. In other words, the elements of the set can be counted and the set has definite limited number of elements. Okay, so just like if I say that S is the set of natural numbers between 10 and 15, so that set's elements will be 11, 12, 13 and 14. So this is easily countable, 1, 2, 3, 4. There are 4 members which is countable enough to tell is as to call it a finite set. Okay. The second one is the P. P is starting from 0 and it goes up to 20. So X belongs to, if I write this, as a set building method or set building form, so X is an element belongs to whole number and where that whole number is less than 20. Okay, and so on. And there can be anything like the set of students sitting in this classroom, which is also a finite set. A set of just like the set of tube lights in this room, which is also a set of finite set. Okay. The next one is in the infinite set. Okay. An infinite set is a set that contains an uncountable or limitless numbers of elements. Okay. So the example of infinite set, what it will be? The set of natural numbers. Yes, which is a countably infinite set. That means we can start the counting, but we can't finish it. Okay, these all are the natural numbers, and it will goes up to infinity. So this set can be called as the infinite set. Okay, so the set of natural numbers can be called as an example of infinite set. Okay. The next one is the set of integers. Yes, the set of integers, or the set of rational numbers, or the set of irrational numbers, or the set of complex numbers, real numbers, which I have also told. These all are the set of, these all are the example of infinite set. In a real life, we can also give examples of infinite set, just like the bacteria is present in this environment, which is also infinite set, or whatever, or the rational numbers. In rational numbers chapter, you have also learned that there are infinite numbers between two rational numbers. So the set of rational numbers present in between any two rational numbers, which is also a set of rational numbers which is infinite. Okay. So there are so many things which is not possible or which is infinite in this universe in a natural way. They all can be called as the set of infinite set. Okay. So now we can say that for about these sets. Okay, the set of whole numbers greater than 1000. So we can easily start it from 1001, 1002 and dot. So what will be like this set? The set of whole numbers greater than 1000. Okay, so greater than 1000, any whole number will be included in these sets. So it will starts from 1001 and it will end on not defined. So this will be an example of infinite set. Okay, because just like 1001 is a member of this set, 10,001 will also be, 1,01,000 will also be. So here it doesn't has any limit. Okay, so this will be example of an infinite set. Okay, so this will be infinite. The set of months in a year. So we all know that there are 12 months in a year. So it will start from January and it will end in December. So there are 12 members. So this is a finite set. Okay. The third one is the set of natural numbers less than 1. So there is no natural number which is less than 1. Okay, because the set of natural numbers starts from number 1. So that set doesn't has any element. So that set will be called as the phi set or the null set or empty set. Okay, so it's an empty set. The set of rivers in Africa. So currently I can't remember that how many rivers in Africa. You can ask your geography teacher as well, or you can search in the internet. So maybe that will be a countable number. So this is also finite set. The fifth one, the set of even prime numbers. So there is only one number which is even and which is prime as well. Can you tell me which is this? Yes, that's 2. 2 is the only prime number which is even. So 2 is the only element of this set. So this can be called as the singleton set. Okay. Okay, so from here we have learned all the examples of set, just like finite set, infinite set, empty set, equal and singleton set as well. But disjoint set, joint set, equal set and equivalent set which we haven't learned till yet, and this will be learned as in the second class, and as well as few more topics in it, just like subset, joint set and power set and everything. Okay, so I'm ending this class here and joining the next class a few times after. Okay.